Thanks a lot to all of you for coming. And we maybe starting slowly as some people are still walking in, but I think that's about it now. Yeah, so hello and welcome to our session, which is called What's New with Spring Boot and Containers. So we put this into parentheses. It's not only things that are completely new, but you're going to see. So this is my colleague Eva. I'm Matthias. We both work for a company called Novatec, which is going to be merged with a company called CGI. So officially, this is our last talk as official Novatec employees. Now, I want to say a few words about ourselves. Eva, you wanna start?
Hello, my name is Eva. I work at Novatec, as Matthias mentioned. I am senior software engineer. I have working with Java and Spring for over 10 years. And just something quickly about me, I choose this picture because I think it represents me quite well, because I'm a very close person and I tend to be happy always. And I don't want to spend more time in this kind of thing, so Matthias, if you want to present yourself.
Okay, so I didn't choose this picture with such a background story. I just took it because I think it was one of the better ones that I have. So if you want to connect to us, you can also reach out to us on LinkedIn or use Blue Sky as well. So my area of expertise, I would say, is in the field of cloud native software engineering. So a bit on the software development side and a bit on the platform side. And this is also kind of the background how we got to this talk. So yeah, let's start like this. I mean, why did we think of doing this talk, and what's the background of this? I mean, both containers and Spring Boot are obviously not brand new technologies. So I tried to pull together this kind of timeline with the container timeline on top and the Spring Boot on the bottom. It's definitely not linear because, I mean, they both date back in time with like change root kind of being the official start in 79 for containers and Java, of course, in 95 for Spring Boot. But things kind of got a bit more interesting around 2013-14 with the inception of Docker, Kubernetes, and Spring Boot. And after that, a lot of technologies emerged in kind of both lanes, like Compose, Testcontainers, Buildpacks, Spring Cloud, Spring Native, and so on. And both are probably able to do a pretty successful life on its own, but of course they are also interconnected. And that's kind of the story of the talk today. We want to show what kind of helpful integration exists and what basically Spring Boot in particular offers to make your life a little easier in integrating that, and also what is beyond the thing of putting your app in a container. Now, as this is going to be quite a bit, we only touch base on the individual parts briefly, and it's the first time we're doing this talk. It's actually, we've only met each other first time yesterday, so bear with us if we get a bit out of time at one or the other stage. We practiced, and we'll try to give you the break after this. Now, when people think of Spring Boot and containers, the most obvious thing is like putting your application, your Spring Boot application, in a container that you normally do, like with having a base layer, then a runtime, and the application on top. But there are, and of course, why would people do that? Containers offer some very good packaging standardization that makes it very consistent. You can port it around into different platforms, scale and repeat things. So there's certainly more. But these are, like, I would say, the core ones. However, they don't only apply for the part of packaging. I mean, you could also use containers for actually development steps. So like providing consistent environments to multiple developers to basically avoid wild growth within these environments. You can do apply the standardization mechanisms in the build step. So to use your containers as build mechanism, also in pipelines, of course. And then testing will be probably one of our biggest parts today, because I guess this is probably the most widely adopted container thing in software development, because it's pretty easy to spin up close to real-world backends with your containers in a very easy way, and we're going to show you some ways to do that. Then, of course, yeah, running the things, potentially in a distributed and polyglot world, and also to like focusing on an enterprise level to scale. So there's actually plenty of integrations, and I guess most of them you've probably heard about. So I hope there are still some things that you might have not heard about that can make your life easier when using those things. So in that kind of flow, develop would probably be the first thing that you start with. However, we decided to put this to the end of the talk and basically only do it if the time allows, because we got more things to say on the other ends. Now, next thing in line would then be build. So when building applications in containers in general, the most common thing to do that is a so-called Docker file. So a Docker file is like a sequential processing sequence of individual commands, which in the end result in individual layers of a so-called container image. And with that kind of approach, it gives you the certain possibility to structure and fine-tune that image. So if you consider that, very often you have like base layers on the bottom, application layers on the top, and some dependencies in the middle. And by the nature of like iterative rebuilds, the thing on top should change more often than the things on the bottom. This, of course, applies also to the world of Java, when like people placing very often jars on the top, then in the jars you have class files, resource files, and dependency jars. So I guess your classes change after every build, your dependencies might not. Now, we try to show most of the things live, and I hope quite a few people in the back. Is that good enough to read? Okay, thanks for that. Now, I'm going to start with this. So with Docker files, the problem is that you have really a lot of options. You can make simple ones, which are not very optimized, or you can make optimized ones, which are not very simple. And a couple of things that I wanted to mention here. So one of the things that I had just brought up is to say you can like split your jar file into individual layers so that you have dependencies, Spring Boot loader, snapshot dependencies, and the actual application parts. So on every iterative rebuild, if only the application part changes, all of these layers can be cached, and only this one will be redone, and you can optimize on that end. This is the part for the application. You can also optimize on the part of the actual Java runtime. So there are the tools called jdeps and jlink, which basically jdeps would analyze your application and figure out which modules of the JRE are actually required to run that application. And jlink can then build a custom JRE, which is stripped down only to what is really needed. So this, on the one hand, makes your image smaller. On the other hand, it decreases the attack surface, because what is not in the container can, of course, not get exploited. Now, why I'm telling you all this? So I'm not going to walk through each and every Docker kind of thing, but the point I'm trying to make, if you apply all of those things, your Docker files can kind of become a own bit of a programming language. And this is something that wants to be maintained and taken care of. Now, the results from optimized Docker files, we can say, okay, try to use a simple and consistent, even across other languages, kind of base image. Optimize the runtime part with jlink and jdeps, and structure your application layer as good as you can. Now, the world of Spring Boot provides a thing called Buildpacks, you might have heard of. This originates out of platform as a service technologies like Heroku and Cloud Foundry, with back then the idea that you push the code to the platform would detect, build, export your application into so-called runnable, which would now be called a container, and takes care of this entire life cycle. This is also possible outside of a platform as a service. So you can basically say, I use that pack command, I tell it, please use that kind of builder image, and then my source code would go in there, the lifecycle would be processed, and I get a resulting image. The big advantage of that is, it is really only one line of code. So I have this I'm not going to do the pack steps now, because since the time is short, but this would basically be the pack command that you would execute in the directory where you have your POM file or your Gradle file, and then it would just do everything for you. if you would want to do the things like I talked about before with jlink and stuff, you need a couple of command line switches, but still it's one line of code, and you get all the benefits that you normally only get in a very comprehensive Docker file. So if you use, Pack is polyglot, you can use it across different languages, but if you happen to use Spring Boot, which I guess people do here, you can also use this as a Maven or Gradle plugin, and don't need the Pack CLI, and can just integrate it easily in your already existing workflow. All right, so much for the, let's say, traditional part of the applications. I'm going to pass on to Eva now to say a few words about native images, GraalVM, and how does that relate or not relate to containers.
Okay, thank you. First of all, let me give you some context about how we use the word image. Through this walk, probably we are going to say a lot of times the word image, but we are mostly referring to the Docker images. But there's another player in that game that are native images. And there are quite differences between both of them, and I'm going to try to clarify, and then we can see both of them. So a Docker image contains, as you can see here, everything that your application needs to run. Operative system, the runtime, the application, libraries, whatever. Whatever you need, you will have it in this container image. But what's a native image is something different. It's a compiled ahead of time into a single binary file. It is smaller, it is faster, and it doesn't need a runtime. So now where the things get interesting. You don't have to pick one or another. You can combine both of them. You can actually package a native binary inside a Docker image, and you can have all the benefits from both of them. You can have the portability, and you can have all the performance that native images can bring us. So that is not about talking, so I'm going to try to demonstrate it, what I was explaining. So I think I'm going to jump directly to the code. I'm going to close everything.
Okay, that's fine.
Okay, first of all, here we have our project for the Graal native images. It's just a very simple project. We have here just the application and a controller to say hello from Spring. Nothing special here. And I must say that I have precompiled all the images because, as Matthias mentioned, we don't have time to be compiling everything in live. So I'm just going to show you how we are working with that. So I'm going to jump to GraalVM. Yes, clear. First of all, for build the traditional jar, we just run the Maven clean package, and we will find here in the target directory, we are going to find this jar file, and I'm going to run it later on one by one, or not. No, I'm going to start. I'm going to run it, and I'm going to see. So, in this case, we are going to start our application using this jar file, target GraalVM. This one. And we can see here that the application has started in 1.048 seconds. I'm going to take note of that, 0.48 seconds. Okay. 1 second. We must think that there is a very small application. But now we are checking what's happening with the native image. In this case, you need to have installed GraalVM in your local machine, and adding the Spring Boot GraalVM dependencies, and just running this command, you will have this binary here. And let's run our application on the same way. No, just GraalVM. So we can see here that it starts instantly. I'm going to take note of that too, because at the end we can compare all of these times. This kind of performance is really important when we are working with scaling up scenarios like scaling pods in Kubernetes, clusters, and so on. So this is very benefit, 6-8 seconds. Okay, I'm going to stop this. Now I'm going to show you the two images, the two Docker images that we have precompiled. Clear Docker images. Grep GraalVM, and we can see this first one is for the jar file, and it has a size of 261 megabytes, and then we have this one that it's the native binary, which has 114 megabytes, and the other one that we can see here, native images, is the one that we build with the command that Matthias mentioned, with pack, and the size is smaller than the other one. So I'm going to run first the Docker image with a jar. Docker run VM 0.0.1. Okay, here we have. It's more or less the same, taking the same time that the first one. It's 1 second and 0.0.5. Okay, and now let's try the last image that is the Docker run GraalVM. No, this is not the correct name. Sorry. Docker run GraalVM demo native. Yes, we got it. And it starts, as you can see, very quick. We are not losing the performance that we were having with the native image. I'm going to point that. So the conclusions for that is by all things to have a better performance and without losing no one of the benefits from Docker images and from native images. So I think that that's almost everything. Matthias, if you want to continue.
All right. I mean, yeah, thanks for this. So we initially said this is like the build part of this presentation, but I gave, as you can see, got already transitioned into the to the run part and demonstrated for both traditional jars and also like native images. And it was actually interesting when we did the demo run before, the native image, like the container executions were faster than like the ones without. So the important takeaway of that is you're not losing anything of putting the things into containers. So this overhead has like almost to zero overhead to your application, and it works with both approaches. All right, so I'm going to jump over this. Then we're going to come to the point of testing. And I mean, as I said, this is probably the part, at least to our experience, which is mostly adopted in terms of container technology, because, I mean, even if you don't use any frameworks or whatsoever, you can just say, I want my database, I want my messaging system, I want my whatever in a container. So with like a plain Docker run, I can spin the things up quickly and easily without installing things on my system. And then for a Spring Boot application, I just need to provide the connection properties so the actual application can communicate with that. However, there are like things that do the same thing under the hood, but provide some advantages for you, especially in terms of like Docker Compose and Testcontainers. And this is what Eva is going to start with now for the Docker Compose part.
I'm trying to not pass the... Okay. Okay, so I'm going to switch to the correct directory. Okay, we have everything prepared here. Docker Compose. Okay, so far we have seen how to run our application in different ways, but what happens when our application depends on other services like a database, which is very common for us. So let me show you a bit this project, and then we can jump to 3 scenarios that I think it's gonna like you. So here in the Docker project, we have again a very simple application in which we have a controller which has some endpoints to do get mappings, so some getters, some posts, some delete endpoints. And then we have here this item repository which uses Spring Data JPI to connect to the database. So what we have done here is just configure everything that we need inside the application properties. So we set the URL, the driver if we need it, username, password, whatever we need. And then here we have a Docker Compose YAML in which we have a very simple image for a Postgres database with the same user, password, and so on. So the first scenario, it's doing on a traditional way. So first of all, what we do is just Docker Compose app, detach it, just to start our database. And from here, just run our Spring Boot application, Spring Boot run. And that's okay. The application is running right now. We have here some requests. We can see if we do a get, it's empty, but we can post some items here, and we do and get again, we can see the items there. We can delete them. So nothing new here. This is the first scenario. This is the most common way on we used to work. But now let's jump to a second, more magical scenario. In this case, Matthias, what do you think is going to happen if I forgot to put some kind of configurations here in the application properties?
Well, I mean, now that we've practiced it a couple of times, I know what's going to happen. But if you had asked me some time ago, I would probably expect what happens is that the application won't start up because it won't be able to find the connection to the database. Mm-hmm.
Let's imagine that the correct response is the application is going to crash.
It's not even going to come to start.
So let's see what is happening. So in this case, oh, what's that? This is not what we expected. If you don't do this spoiler.
I'm too honest.
So the application is running, and maybe you are thinking, what kind of sorcery is that? Well, most of us are asking the same. And now let's keep it on this way, and let's jump to the third scenario, because I'm not going to reveal anything yet. The third scenario is entering in God mode. So we have no configuration here. We have not Docker Compose app. So I'm going to do that. So we don't have any Docker Compose. We don't have the application properties. We don't have anything. And if we run our application again, let me see what's going to happen. Here we can see that first the application is running. It's working. I'm going to do some kind of tests here. I'm going to get all items. There are no items. I can create one and get again. Sorry. And we can see it here. So this is the best, the most easy way. I'm sadly going to reveal this magic. And the magic is, I think I've closed it correctly. All the magic is set here in the dependency that we have here. If I comment out this dependency, everything is going to crash as we expected from the beginning. So let's do a test just to confirm what I'm saying. I'm not lying. You can trust me. I hope, yes. And this is what happens. With this dependency, everything is made automatically. It searches in the compose YAML for all the metadata that we need for configure everything. It starts the Docker compose if we don't have it started, and waits until it's healthy to start our Spring Boot application. And now that I have revealed all the magic, Matthias, I think you are going to show us something related with test containers.
Yeah, I mean, so this is one way of taking some advantages of, let's say, Spring Boot magic. I mean, it's definitely a helpful thing. If you say you don't have to worry about the configuration, the application properties, and the application just takes it out of the Docker Compose. That also, of course, means if you update your Docker Compose and have changes there, then it's also going to reflect in your application. And this is something that people tend to forget. And then if there's a mismatch, of course, between the compose and the properties file, your application is not going to work well. So that's definitely one pitfall you can avoid to answer that question from before. Another way of doing that, as mentioned, is using the test containers technology. So I'm going to switch directory. I mean, as you can see, we're going to share this repo to you later on. And we basically just put directories for every kind of use case. The underlying app is mostly kind of the same. So it's just like having multiple projects like in one repo. Now, where am I going with this? So I'm going into test containers here.
Should we run the reset or not yet?
No, I don't. I think it's fine. Okay. So do we have any? So there is, yeah, we probably should just stop this container and make sure nothing is there. That's a good point. So, oh yeah, sure.
When you turn Docker Compose with database, how application gets data?
The application, well, this is a good, I mean, under the hood, this Docker Compose dependency checks for the existence of a file which is either called Docker Compose or Compose YAML. And it reads out the properties of that file. So in this case, the PostgreSDB, the user, and the password. And then injects it automatically into the application, so you don't have to do that manually. That's the thing underneath. And a similar thing happens actually if you use test containers. So who in here has been using test containers before? Okay, as I expected that. So this has been around for a while, and it's super easy and simple. Of course, I would wonder if you had not used it. But the things how it worked until Spring Boot 3.1 was I put it into a folder called old. That you would normally say, okay, I have my test class. I annotate it with test containers, and then I use that annotation basically to fire up that container. But what I had to do back then is say, I need to configure the properties automatically. So when the test container starts, it has some default settings, and they would now be mapped into the Spring Boot properties. So that would always work as well, but you would have to define this. Now, with the newer versions in 3.1, a couple of changes happened. So you have this test containers configuration class. And what you need to do here is very important is the annotation service connection, because that will automatically take the service, like the connection details, and puts it into the Spring Boot environment. You could, of course, override them if you want. I commented this out, but it would totally work without it. So if I go there now and just say Maven test, you can see in the logs, it's going to connect to Docker now. It's going to start all the things that it needs, run through the test cases, and you can mix old and new versions of it. It totally doesn't matter. And then it walks through the tests, and once it's finished, it goes away again. The problem with this, it happens rather fast, and I'm not able to show the actual live presence and going away of the containers unless I'm really typing pretty fast. But there's something else that has been added. So there's a new Maven goal called test run, and you can see I also have a main class, or a class with a main method in my test folder. And what this one does, if this one is invoked, it invokes the actual main class of the application, but it passes the test container configuration to it. So if I do like a Maven Spring Boot test run instead of run, it's still going to run the main application, but it like includes the test container configuration, and that also means you don't need to specify anything. So the application is now running, even though I didn't have any kind of container before. And if I check here for Docker PS, I can now see they are there, they work, and I can basically interact with my application. I maybe have some requests here too. So yeah, and what I also did, I wrote a custom controller in this application, which would actually check for those connection details which have automatically been injected. So I basically use like this constructor injection here, and then I iterate over all those details. So if I actually go to that request and run it, okay. I had to change it to port 8081 before because I had a port conflict. Who would have that? So if I try to run it again, I can see it here. So I have 3 different connection details. One is for that Liquibase and one for Flyway. And then I have this connection from the Postgres container. And here you can see all the values that I have never set. I mean, if I go into the resources application properties, it's all commented out. So again, it's a very similar mechanism under the hood that Eva had shown for Docker Compose, which applies here too. So you can't do much wrong with the names and the properties if you don't have to specify them. All right, so basically to conclude that, I think it's the other, you have different options. I mean, you can still do all the things manually, but the obvious drawback is you have to configure your container and you have to configure your application for the container. With Docker Compose, you only need to put the definition in the compose file, and then this is like an external kind of source. The Spring application will read it and automatically load the things into that connection details. On the other side, test containers work in a similar way, but you don't specify the properties for the test container in an external file, but directly in the code. So of course, both of them have pros and cons, but I certainly think if you pick one of the two, instead of doing it all manually, you can certainly have a benefit from that. All right, now AI. I mean, this is something. It was a very late addition because this just came up when we had already submitted the talk. And I mean, nowadays you can't do a talk without AI. This, in case you haven't heard, this might be a new hype topic, and we also want to have our share of that. So this actually, this concept can be extended for using test containers in a conjunction with local LLMs. So you might have heard of Olama. Recently, Docker has also adopted a thing called the Docker Model Runner, where you can run, as the name says, local LLMs. And you can just use them in the same way with test containers as I have just shown. So I'm going to go back here and say, I'm going to stop my application to avoid further port conflicts. And I'm going to switch the directory to Docker Model Runner. So I have two, if I do Docker Model ls, you can see I have two models, this Gamma and this small model. One is 2.3 gigs at a 256, doesn't really matter. And technically, I can handle them via the Docker API just as I handle containers. And in the same way, I can also access them from the Spring context. I mean, this application, of course, in the POM XML has the Spring AI dependencies down here, but also the test container stuff. So if we look into the test classes, you will see that my test configuration, in this case, I inject the properties halfway manually. So I specify which is the API key and which model do I want to use. The endpoint, how to access the Docker engine, is being taken from that Docker Model Runner container. So as you said, I had two models, the Gemma 3 and the other one. The other one is actually specified as the default in my resource file. So if I do a Docker Spring Boot, if I do a Maven Spring Boot run, it would pick this one. But if I do a Maven Spring Boot test run, it will of course load the configuration. No, it doesn't. It's the wrong directory. Okay. So you see, it's all live. Test run. This is going to come up, and it's going to expose a very simple endpoint. So it's basically just an endpoint to chat. And if I say now, I want to chat with you, and I'm just going to ask, what's your name in an HTTP call, it's going to come back, hopefully, and saying something. My name is Gemma. So it picked up the configuration from the test container properties and kind of overrode the ones which are in the standard properties. So you can extend the things that we just have shown for local LLMs as well. And we just spoke to Oleg from Docker before, and he said it's now also available in Docker Compose. So basically, that's where the story kind of completes. All right, so much for the testing. Finally, by the way, a few words about Kubernetes and how do things work in a scaling environment.
How about time?
How about time? I'm going to look at the time in a second. We don't have a watch in here or something like that, right?
No, because we have everything in whole
Yeah,
screen.
just you go ahead. This is
Yeah, okay.
yeah. We still got 10, 15 minutes, so no worries.
So I'm not a Kubernetes ninja, but that's okay because we've got our, of course, SRE team and our best friend Spring Boot, which is going to help us out. So I'm going to switch to the project here, this one, and I'm going to tell you what we have here. City Kubernetes, okay. I'm going to split this right. Okay, I think more or less we can. With pretty much zero config, Spring Boot give us a built-in support for liveness and readiness proofs, and of course, Actuator makes all the magic visible. So I'm going to show you a bit what we have here. We have this YAML file for the deployment. In this case, we have configured these endpoints that Spring Boot provides us by default. And what we have done here is just create a couple of custom health indicators here, one for liveness and the other one for readiness.
Just one quick thing.
Yes.
Who in here is not familiar with Kubernetes? Okay, only very few hands, but just as a quick summary, I mean, what those two probes would actually do, they don't have anything to do with Spring Boot at this point. I mean, this is just a point where Kubernetes says, this is a path how application can tell Kubernetes, I am now ready to accept connections. This is the readiness probe, or I'm alive or not and still healthy. In case the readiness probe fails, this component in Kubernetes will not get any traffic, and in case the liveness probe fails, the component will be killed by Kubernetes. So it's just to put this into place. And since we had time, I thought I squeezed that in.
Okay, so what I'm going to do now is close everything again, close all tabs. So I was saying that we have created a couple of custom health indicators here to force the controller to simulate these two status down and up for both things, for the liveness and the readiness. And I'm going to open that file here. Okay. First of all, I'm going to check that QCT. I have applied everything. Okay, perfect. Now let's see what pods we have here running. I'm going to use my command. I'm sorry.
Yeah, that's fine. No need to apologize.
No.
It's your demo.
Something like that. And here we can see that we have this pod is ready, is running, everything is okay. Right now we have these 3 starts here, restarts, because we have been playing with that like a half an hour ago. And what we are going to do is just force the status to jump on a down status. So I'm going to go to these requests, and what we are going to see first is for readiness. I'm going to force to simulate that readiness is down. So for that, I call that, and it says, okay, readiness is down, and let's see what is happening here. Just, I'm going to, okay. Here we have, this is the same pod, but it's saying that it's not ready. As Matthias has mentioned, it's not accepting traffic anymore. If I want now to force the readiness up, this is what is going to happen. What is going to happen is we are not listening anymore at this point, and we cannot go to that endpoint. So for that, I need to do some kind of trick. I need to do a port forwarding just to jump directly to that place. I'm sorry for copying. Okay, I've got this, and now I can run it again and see. I'm sorry, how readiness now will be up. Now readiness is up. We can check the actuator here, and we can see that everything is up, everything is running, and we can see there that it has recovered the ready state, and we can accept again traffic. And the last point that I'm going to show you is if we force a liveness down, because in this case it's going to happen something a bit different. Now it's not ready because we are saying that the liveness of the pod is not healthy. And I have configured in the YAML file some threshold for some seconds, and when there are some seconds that it's not ready, in this case what we are going to have is a restart from the pod to get it healthy again. So with this Spring Boot configuring things like health checks and readiness and liveness, it's not only easy, it's almost effortless. You don't need to have everything by yourself because you have most of the things auto-configured, and it helps us to avoid kind of mistakes and so on. So more or less, I think I have finished with this demo. And Matthias, how we are going on time?
We're good on time. Okay. I mean, I would just like to re-emphasize quickly on that last point. I mean, when you run your apps in Kubernetes, and we see that there very often, I mean, Kubernetes is technically blind to what's happening inside of an app. And I have seen really wild kind of things that people put into this liveness probe, on this readiness probe, to actually simulate something. And of course, if this probe sends the wrong signal, Kubernetes will react, and then you might have very unwanted effects. Now, this is certainly an advantage with Spring Boot, that you only need to add the actual dependency and put the default endpoints in there. That would at least give you like a readiness check if the HTTP port is open and stuff like that. And will certainly help that no unwanted traffic gets to a pod or to Kubernetes, to like a Spring Boot application, unless you really want it to. If you, of course, I mean, also important to understand, the thing that Eva did here, this is not something that you need to implement by yourself. This is just implemented for the purpose of this demo. In the end, if you have custom readiness checks, for example, you want to check that endpoint or that database, then you would do it in an equivalent way, and that's what your actuator would return. And then basically tell Kubernetes how to handle these applications. All right, so we actually have a bit of time for the last part. So we've seen that. They basically integrate also without it. But if the Spring Boot app interacts with the Kubernetes API, you have a more seamless integration into that environment. Now, for the part of development, one technology that I just wanted to bring up quickly, I can't really go into a lot of depth, is the so-called dev container technology. So we had Testcontainer for test. Of course, we should have dev container for development. This is something which has also been around for a while, originally coming from Microsoft. And what you need to do there is putting such a so-called dev container JSON specification into the either like a dev container folder or the root folder of your repo. And in this one, you can, similar to a Docker file, specify how the development environment should actually look like. So in this case, I said, okay, I would like to have the Java 21 base image. Then I would like to have the latest features of Maven and Gradle. I want SDK man. I want the Spring Boot CLI. I want a Docker engine and kubectl. So that means that everyone kind of uses that repo and has an IDE which is capable of handling dev containers, and most of them are, like IntelliJ is, VS Code is, of course. Then the environment for all of those would be the same. So you can seriously nail down which is the version of Java, which is the version of Maven, and you avoid those little differences that have unwanted effects in the end. In the customizations part, I mean, this is now a bit VS Code focused. You could, of course, have like an IntelliJ section here as well that would define your IDE. Okay, this is like the settings that should be automatically applied. And of course, these VS Code extensions only work for VS Code. In case there is nothing like such a feature, like which is in the list here, you can also still run manual commands. So for example, Buildpacks doesn't have a feature. Then I would just execute this command to install Buildpacks locally, manually. We didn't run the demo today in the dev container because the part that I showed with the Docker model runner would not work within such a dev container. So this is something that you basically have to run locally, and this is at the moment only available for Mac and Windows. But for all other things, it's going to be fine. So do you have your Chrome browser open?
Yes.
Where is this?
Is this one?
Oh, yeah. Right, so this is basically our repo, and one of the easy ways to exploit the dev container technology is if like you must be signed into GitHub, and then you can either like clone your repo or use code spaces. And if you say you want to create a code space, it's gonna set up this development environment for you in the cloud, and this one is automatically gonna pick up that dev container specification. So if you want to do tell people, oh, here you want to try my code, and want to make sure they're using the right settings, puts a specification in there, and then it's gonna do that. So just the first run is gonna take a bit of time because it's gonna say building code space now. So under the hood, it's walking through all those steps which I had in my dev container specification, and once it's finished, you have all the setup that you actually want to have. Right, so this kind of brings us really to an end. I mean, yeah, you have seen there are many different integrations between Spring and containers. I hope there was something new in there for one or the other of you. This is the repo, like the code to the repo, if you want to play around with it, but it's still very experimental as the entire talk. And so I'm going to look at Vova real quick if we have any new questions, but if you have any right on your mind, we still have a few minutes that we can answer things. In case you haven't, also if you have the feeling we are missing something essential here. I mean, we're not developers from Broadcom or like the Spring community. We apply those things in our daily work with our clients, and of course, it might not be the case that we just know everything. So if you say there's this thing that helped us a lot, please feel free to tell it to us, because I'm pretty sure we're going to repeat that talk in the future and would like to keep it up to date. And with that, I would say thanks very much for listening, and I wish you a nice rest of the conference. And yeah, about that Vova app, you can also rate and give feedback there. I mean, even if there's things that you didn't like or things that you think we can improve, put it in there. We would greatly appreciate it. Is there a question in the back?
Yeah.
Oh, sorry.
We all know the guys who have 20 projects open.
Yes.
I mean, I'm not the guy, but I know some. Regarding the Docker Compose module, is it possible to map those database ports randomly, like in the test containers?
Yes. I mean, if the in the Docker Compose part, you need to, you need to specify it in the compose file, but you could actually specify a random thing there. And the Spring Boot application would pick it up. It would take it right from there.
All right, thank you.
Yes?
So Docker Compose and Testcontainers, they are nice features to run locally, but how does that work properly on a build server like GitHub, so they don't have always a Docker engine?
Well, if you don't have, nowadays, at least in our terms, most build engines come with some kind of container support. If you don't have that, most of those advantages are not applicable, because if you require container technology, then that's the prereq. For some of the things, no, I think all of since our talk is about containers, we talk about containers, and I don't think there was anything in there that you can just bypass container technology. Otherwise, you would have to run the services remotely somewhere, and where you could apply, of course, these technologies, and then you need a network connection. But of course, this would not reflect your test in an ideal way, because you have the network latency, and it's not as close as it can get.
Do you have some Docker, or what is your setup, how you do that? So you have a command running somewhere, or is it because always Docker in Docker is a security risk, so enterprise companies don't want to enable it because of security stuff?
Most pipeline, within a pipeline, don't take my word from that, but I would say it's still fairly safe. We have used the Podman approach as well, and most of the pipelines provide that already by themselves, so there's a supported solution that you don't have to configure manually then.
Okay, thank you.
Sure. Do you have anything to add? Did you have anything to add? Okay.